Good afternoon, morning, or evening, wherever you are. This is Robert from the We Are Millions team, and today we are at the Operators Day. This is the Operator Day of the We Are Millions event set up by Swarm for the Fair Data Society. And today we will be looking into nodes, how to set them up, what is involved with setting them up, what can they offer, how do they impact services provided by Web3 projects, and how do they impact society in general. For that, we will have several workshops today. We start off with one on setting up Swarm nodes, the Swarm B nodes to be exact. Then we'll go into a workshop and a talk by the Fluence team, how to set up their nodes. Then we'll dive into one by NIM. I'm very looking forward to that one. Then we'll dive into one by Avado, how to run a Swarm data node. Very curious to see where that will take us. And we'll end the day with a panel via Twitter Spaces, led by Denise Royo, about the impact on society of these Web3 distributed networks. So we got a lot ahead of us. So grab your coffee and join us for the next sessions. And we will start off with the Swarm B workshop, which will be led by Anatol from the Swarm team. Anatol, are you online? Hi there, good to see you.
Yeah, I am. Hi.
Hi.
Very good to be here.
Let's see. Anatol, could you please introduce yourself for the audience, what you do with Swarm and what you will be showing us today?
Yeah, sure. My name is Anatol. I'm part of the core team. I will be doing a demo on the ultralight mode, which is a chainless mode. I also have to be honest, my internet connection is not great. I mean, that applies for the whole south of Mexico. So hopefully there will be no interruptions. But if they are, I'm going to take just 2 minutes and move to a different place, hope for the best. And then
if that's needed, we'll entertain the audience.
So
we'll make it work.
Yes, so that's yeah, sorry in advance for that if that happens. I will I'm happy to start presenting the ultralight mode. I haven't done this before, as what I mean by that is being a panelist, so bear with me if I need to reconnect or something, but I guess I'm going to just share my screen and go on, or
take it away. We'll be here and we'll relay questions from the audience on Discord. And for the audience, don't forget, this is another session. So for those who have the We Are Millions NFT, you can claim experience and grow your avatar throughout the event. And with that, I'd like to give the floor to Anatol.
Okay, thank you. So as part of the upcoming release, one of the major features that we are introducing is a new mode of operation, which is called ultralight mode, for the lack of a better qualifier. It implies basically for the B to operate in a chainless mode, so without the need for a chain backend. So what that allows us to do is easily onboard people, because we don't have to do crypto onboarding. We don't have to go into those subtleties that go with it. So we can easily start a node, we can easily demo it to a potential user and get them hooked, so to speak. So what I'm going to do in this presentation is show, first of all, since it's still work in progress, it's going to be released very soon, but it's still work in progress. I'm just going to be showing mostly the inner workings. So you won't get to see the shiny, easy to use, user-facing, user-friendly kind of experience. But that is coming. That is down the road. We are in this demo. I'm just going to show you how it's going to work under the hood. So be ready for some terminal.
And please, before we do that, perhaps could you also explain why one would run a node as for in this case?
Yeah.
For the first time viewers. Yeah.
Yeah, a first time user would want to work in this mode because of speed. It's starts right away and it exposes you to the whole Swarm ecosystem in seconds. It's painless, it's user-friendly. As I said, later is going to be also really with a really nice user experience. So ease of use, if I could say, in one expression. So this is the mode that you want to use when you don't have time, but you really want to use the most of the Swarm ecosystem.
Okay.
With the smallest effort from your part. So in order to do that, what you need is obviously to have the B binary. I have it on my machine, so I'm just going to share. Let me quickly close the embarrassing windows, which is mostly my emails and stuff. Okay. So desktop share, and this is another one. This is another one.
Be aware we are broadcasting.
And we are. That's fine. This is a clean kind of workspace. What I have is B version. Let me move around. I'm on dev branch, so also maybe not the best branch to be on while demoing, but that's the reality. This feature is part of the upcoming release. It's being tested as we speak. Now that we have the B installed, all we need to have is a config file. So and this is kind of the most important part, that the config file to get started is really simple. In fact, you have to specify that you don't want to use a chain. So chain enable is going to be false for the demo. And also you want to start in light mode. By the way, this is why it's called ultralight mode, because light mode is already a kind of a low resource friendly mode for B. So B usually by default will run in full mode. That means it's going to engage in all kinds of protocols, and it's going to store chunks locally on the disk. I'm having a message. Participants can now see the screen. Can you see my screen? Can you confirm?
Yeah, we see terminals.
Is it Zoom playing? Okay, thanks. Zoom is making me nervous. Anyway, so now if you want to run B in a low resource environment, you may not be able to store chunks. So for this purpose, there is light node. You enable light node by setting the full node to false. So you won't be storing chunks. You'll be engaged in a subset of the protocols, of the functionalities. There will be changes in how forwarding happens and things like that. Now there is ultralight mode that I'm demoing right now, which basically you take the light node and you remove the chain backend from it. So that means that has some implications. Besides the good part that you don't have to do the onboarding, you don't need to do depositing and the checkbook deployment. You also have some downsides, and that is specifically things like overlay verification. So what is overlay verification? Basically, we want to make sure that the network is secure and there is no possibility of a bad actor forging or mining overlays. So we have a certain mechanism in place that will, based on the handshake given overlay, based on the transaction and the block hash, it will compute the correct overlay, will compare, and if the incoming handshake has a different overlay, presents itself as someone else impersonating someone, or just plainly mined an address, it will be rejected. So this is how we make sure that all participants in Swarm have a valid and a valid address, a valid overlay address. Now, how do you do that if you don't have a chain backend? So this is tricky. So for this purpose, we have introduced two configuration parameters. When the right now, you will have to add them manually to the config. Eventually, this config will be generated. You want to provide both a block hash and a transaction hash, because both are involved in this verification process. They are added as two configuration parameters right here. And these are all the all the ingredients you need for the ultralight mode recipe. So chain enable is false, means we are not going to any RPC that faces us, that exposes that chain backend for us. Full node is false. We have a transaction and a block hash, and they go together for the overlay verification. How do you get these two values? Right now, we have a faucet that takes an Ether address and will give you these values. So for instance, if I were to start a mainnet based on this config, it's going to give me my Ethereum address. So I'm going to expose it here. I'm going to curl, so call the faucet for the transactions. Hopefully without hiccups, it's going to give me some values. It's giving you more values than I need, but this is basically development mode. So please ignore the rest of them. We need the next block hash for B. We need the transaction hash. So let me check 404, 1 is, okay. This being saved, we can go and start the mainnet. Start the mainnet. And with some lock, we can see it here in the logs that we are using a certain block hash with the ones provided. And here we go. We are connecting to peers, so we are joining the Swarm. I mean, I know it's not too exciting because it's basically terminal, but we are joining the Swarm without a chain backend, just based on this little effort to get these two values and then putting them into the config, and we are good to go. And this can be done it will be done transparently in the when we have the UX ready. So this is kind of the demo, the main part of the demo.
So you'll be joining without needing to sync locally, basically. So that you give an endpoint of the state.
So you can join the swarm without having to be connected to any Ethereum backend. So without needing a checkbook, without having to do a crypto onboarding part, which is maybe for we have looked into some category of users that would be interested in using Swarm. So there are people with different exposures to chain. So they might be lacking some knowledge or time to do a crypto onboarding, to have a checkbook deployed. So they want to start easy. And in basically 2 steps that will be done under the hood anyway, they can get started and join Swarm and maybe even download some stuff. Let me see if I think I uploaded some hash earlier.
And is this running on testnet or mainnet right now? I'm looking at.
It's mainnet. This is the command that I use to start. So I do bstart, I provide mainnet. You can also provide it in the config, network ID, 1 for mainnet, 5 for testnet. I do it from the command line just out of habit. And you provide this config file. And maybe to reiterate this config file, basically these 4 configuration values is all you need. These 4 down below are for the dashboard, some debug to have some extra data here, and a password that maybe I shouldn't be showing, but this is an instance I'm going to discard later. So also I think I uploaded.
These are questions coming in from the audience. I'll sum them up.
I have a hash, and I uploaded it later. Sorry, I uploaded it earlier to be downloaded later. And let's see if it's that one. It's small enough. I think it's this one. So how do I do it? Would this work? Yeah. So this is the hash I uploaded via the mainnet gateway. I got the hash right here, and I was able to download it from the local host 1633, which is this instance running right here without a chain backend. And this is kind of the big, I don't know how big and impressive it is, but a lot of work went into it. And once it's done, it's going to make a very big difference in how easy people can join Swarm and how easy can they be exposed to what Swarm has to offer.
We got a question.
It's also worth mentioning how easy. Sure.
Yeah, go ahead. It's worth mentioning.
Yeah, it's worth mentioning that you can gradually switch from the ultralight mode to the light mode to full mode, basically by fiddling with these 2 values right here. So let's say right now to enable the chain. So I go through. I also need a swap endpoint. So now that the chain enable is true, this value is going to be taken into account. So we're going to make a call for it. So let's see how that look like. So if you see here, we are starting with a disabled chain backend, and in a moment it's going to show us that we are starting in light. Well, the logs kicked in, and basically we are starting in light mode. with a chain enabled. So that means at this point we can buy postage stamps. Where's my cursor? But I'm not sure I have funds, so bear with me. Okay, so this, I think this is looking for.
So for the viewers, what would you need funds for?
Mm-hmm.
For the viewers, what would you need funds for?
So the funds is basically, in ultralight mode, you don't have access to the chain. So basically you don't buy postage stamps, so you don't need funds. When you move to the chain enabled, so you want to upload stuff, and this is where you need, because in order to upload stuff to the network, you need a postage stamp. You buy that using the CLI, like in my case, and you use the ID of the batch load stuff, and with every upload is going to get counted against the stamp. It's going to get used, so to speak. So you have to top up at some point if you want to continue using the stamp and uploading data. So for that you need the blockchain. So in ultralight mode, there is no upload capabilities, just download. There is also accounting is done differently. If we were to go into a bit more details, so the way we do accounting is to check how much data has been uploaded, downloaded, and then we do settlements. Because these settlements happen on chain, and the chain is disabled in ultralight mode, basically we don't do that. So that means eventually the peers will start blocklisting you if you continue doing it. So if you run out of the free riding capabilities of the swarm. So there is a certain tolerance to extent of which you can ride for free the swarm. So eventually you'll have to enable the chain. You will have to do the crypto onboarding, add some funds, buy postage stamps, upload this stuff to Swarm, and have it there, stored.
Is it comparable to like BitTorrent upload-download ratios in such a sense that you can't free write until you at one point balance it out again?
Yeah, it's the same concept. I mean, people at some point they might. So we have some defaults. How often we do time-based settlements or other kind of settlements. So we have defaults. Some people, some node operators might want to tune those. So some people will allow you to do more free riding. Some people less. Depends on their circumstances. How cheap is for them to run the nodes, I guess. And it's impossible basically to tell what ratio you need to hit to start, being to run out of the free riding kind of capital, but it's there somewhere. So don't yeah. So,
we have a load of questions.
Don't abuse it, basically.
I'm gonna just throw them all at you. One was, sure. Is it possible to install a B node using Ubuntu on Windows 10 or 11? Yeah.
Is it possible to install a B node on Ubuntu that runs inside the VM yes. machine on Windows?
Yeah.
Yeah, absolutely. We are not imposing any restrictions. Yeah, as long as you have access to the network, to the wide internet from the virtual machine, you're good to go. Just make sure it's not, you have a persistent storage for your keys to not get lost and stuff, or just make backups and you're good to go.
Okay. If you're running ultralight mode, does it also interact with B dashboards and BJS? It's a question for one of the operators.
Yes. Yeah. In fact, sorry for the messy demo. I was meaning to also show you the dashboard. So completely skipped from me. Anyway, so B dashboard is getting ready for the ultralight mode. Right now we have this little warning saying that, okay, we are running on dev. That's also going to go away soon, as soon as we release. So you're going to see the exact same things, except that the checkbook deployment and funding is not there. And that is because there is no checkbook deployment and without a chain. So right now, there are things to be improved on the dashboard in relation to the ultralight mode. For instance, right now, even if you go to files, normally you should see them, but right now it's taking you back to the node status. But if we release, this is going to be a kind of a nice experience in all modes of operation.
Of course, yeah. And user ready.
Of course.
And because we're almost nearing the next session, I'm wondering if I want to run a node, what does it take? What kind of hardware would be required to run it?
So obviously there is a kind of a lower limit of how. So for low resource environment, you can run a light mode on things like ARM and Raspberry Pi and even mobile phones, or mobile phone level of throughput and CPU and memory. However, if you want to run a full node, somewhat of a consumer level laptop would be more advisable because of the amount of parallelism that takes place in the process, and a proper CPU is definitely a better option than any mobile or ARM.
Is there
Hope I'm not
minimum
insulting anyone by saying proper. I mean, just a general purpose CPU.
Is there a minimum amount of storage you can allocate?
Yes, we start with 20 gigs, although you can tune this value as well. But considering that the purpose of Swarm is to store data, we advise to go higher than that. Besides, modern storage is relatively cheap, and so yeah, it's going to allocate 20 gigs. It's versions, so sometimes in between versions, like the upcoming 1.5, we might require some more for the expand contract phase. But that's that's temporary because it's going to release once the compactation kicks in. So 20 gigs to start with, hopefully more than that.
Okay. In the competition, you mean competition between nodes to host the same data?
No, sorry. So sometimes when we change the way the format, so we're introducing a new Sharky. It's called Sharky. It's a chunk storage for B. So we are moving away from some of the components we used earlier. So in order to migrate the old store to the new one, it's going to temporarily have to use some extra disk space. But that's just temporarily until the migration is done. So basically, you're going to start the process. You're going to see it doing some stuff, which is migrating from one store to another. But once it's done, you're going to get back to hopefully less space than previously, if we did optimization correctly. But yeah.
Okay. And if I want to know more, if I want to find documentation, if I want to run a node, try it out, where do I find that? Where do I go?
So with every release, we update the bdocs on ethswarm.org. And this includes the functionality of the ultralight mode operation mode. Yeah, it's thoroughly documented, both the process, how to get it working in this mode, and also what it implies for you, for your wallet, for the other participants in the other peers that you're connected to in your neighborhood.
So that's eswarm.org, that's the website. And then I click on
link.
documentation. If there's a repository, I can dive in, perhaps.
So I have bookmarked docs.ethswarm.org, and it's a really nicely compiled set of documents with a navigation and a nice and a night mode, if that's a selling point.
We'll share it with the viewers as well in the chat. Yeah. Okay. Then, Anatol, thank you for taking a moment to share the new developments with us. And yeah, if there are any questions that might pop up in Discord later, then please jump in, of course, and otherwise we'll relay them to you. Because now, after this demo from Anatol about the swarm nodes, we'll continue with one by Fluence Network. And for that, we have another guest speaker, but I do not see him in the chat yet. So I'm gonna ask around. My colleagues have seen. No, okay. In that case, what we'll do, let me see, today, are you around? Today, Fias?
Yes, I'm here.
Hi.
Hello, hello.
Hello, hello. So, with regards to the demo you just had by Anatol, I was wondering, are you running swarm nodes as well, by the way?
Yes, yes. I'm running actually in Windows subsystem for Linux too. I'm running B nodes, not in a Docker mode, but pure B. Had some problems with 1.3 version, but later versions are working just fine. I'm rather excited with this light mode. I think it's a very prosperous, and it will enable a lot of people, to reach into the network and get some data down. I would like to know how and when you get blocked. So what are the limitations on the bandwidth? How much can you download in how much time? And are you unlocked from after you're being blocked, and when you're unlocked? So these are the questions that I have. Also the memory consumption for the ultralight nodes. That would be something that I would like to know. Yeah, but yeah, running them in dev mode. And
Anatol's still here. If this next speaker is not here yet, then we can ask if he can answer these questions, perhaps.
Yeah, not all of them. We would have to look into the we haven't actually done research in how the memory and CPU behaves in different modes. We know that because it engages in fewer protocols, inevitably it's going to spawn fewer routines, and that would result in better performance, but no benchmarks or concrete data to back my statements.
Okay. Also, yeah, on Windows, on like a local machine, I don't run with a big clef. I couldn't make that working.
Okay, if you reach out, we can help. It's fairly easy. Maybe there is a bit in documentation missing, but honestly, there is nothing complicated about that.
Yeah, probably I'm just like missing one step or two. It shouldn't be such a big problem.
Drop a message on Discord. I'm happy to jump on it.
Thank you. Thank you.
And where on Discord would that be, by the way?
The Discord. So we have a channel. I'm going to share. I have it bookmarked. I'm going to share it in the chat right away.
So yeah, he's going to be pasting it into the chat of the event, the Discord. But I asked because there's a support chat for Swarm nodes as well and operators. There's a Swarm Discord where also alpha and beta testing is done with new versions and where people can reflect and can ask direct questions to the team in case there's problems with setting up a node or challenges, should I say. Okay. So this ultra light mode, just curious, if this is light, would that mean that, for instance, would it be possible to run a node from a phone?
In theory, yes. In practice, we didn't have a lot of bandwidth to test it, but considering that it doesn't need storage, and that is a bit of a bottleneck with phones and low-end devices, as long as there can be a little bit of a problem with the bandwidth when it comes to upload, download. So, but probably if I have a good Wi-Fi and a modern phone, it should work just fine. Both light mode and ultra light mode.
Okay.
Are you planning to support like WASM or like have the packages available for Objective-C and Swift and Android?
So there have been a lot of discussions about that in the past, and I think due to how we set our goals and priorities, right now that's not on the radar, but yeah, everything is possible. We'll just have to see what the demand is and what is the features that are going to, be the most requested and used.
That's good to know.
Okay.
I think that Fluency, Evgeny from the Fluence arrived. So
yeah.
Hello.
I see you come here. Hi there.
Hey.
Hey, good to see you.
hello.
Hi.
Hey, good to see you guys.
Nice to see you too.
Okay. Well, in that case, let's continue with the next session. Thank you today, Anatol. Thank you. So we just had a presentation on setting up a Swarm node from Anatol. Evgeny, please introduce yourself and Fluence and yeah, what you will present us today.
Sure. Hey, everyone. I'm Evgeny, co-founder of Fluence, where we built the peer-to-peer computing protocol. I wanted to do the presentation about what we are building, why it's important. So let me share the screen. So I assume everyone can see my screen.
Yeah. I see a Google slide deck.
Yeah, okay. Yeah, so we call it Web3 native computing. And basically, if you think of the evolution of computing, we sort of move in to new generation of platforms of like computing platforms in general, from desktops and mainframe to cloud computing, and to finally to peer-to-peer platforms. And when we say, computing in general, it's actually about it actually includes and like when we say computing, or like when we say peer-to-peer, it actually includes different things. Like we are at the stage when we already decentralized financial systems with new computing paradigms like blockchains. So we have something like some new peer-to-peer platforms, a lot of actually peer-to-peer platforms there. And we also at the stage where we are sort of rethinking the internet infrastructure related to storage protocols, networking, identity, and things like that. And it's always like the conversation about computing is always somewhere around, but what is happening in terms of movement into peer-to-peer computing? So we have this idea of smart contracts of the blockchains, basically like the code that can be executed on blockchain, which is the network powered by consensus. And basically it means that whatever we run on such networks, the code will be repeated by all the nodes on the network. And it means that from the computation perspective, it makes this computation quite expensive or restricted, because it should be deterministic, because different nodes of the network have to get the same result when they rerun the computation in order to get consensus. So this model is very specific. It's kind of like perfect for digital assets, for NFTs, for DAOs, DeFi, things like that. But if you think of more traditional use cases like backends of applications for which we use clouds today, it's probably not a great fit. And there was a big attempt in the blockchain space also to create the decentralized hardware marketplaces. So there are some examples of such projects, and they are mainly focused on high-intensive computations, like on some video rendering, scientific computations, things where you need to really distribute the huge task to different devices and get them collectively work on solving complex computation puzzle. But we really didn't see the something that would be like general purpose enough and easy enough to switch from traditional cloud infrastructure to the new thing. Like that would not really require users to learn about gas, for example, like blockchain forces users to know, or would allow to just bring your legacy API that you have in the cloud and put it on this new infrastructure, and would be also native to the new Web2 world, where we already have all of these blockchains and we already have all of these storage protocols and things like that. So we missed some kind of general purpose peer-to-peer computing, and this is basically what we are working at Fluence. Also, like a few words about where the demand comes for it. Like basically like two things. Web3, in the Web3 space, not everything we want to do can be done on blockchain, purely on blockchain, because like even if there are a lot of applications natively living on chain, you still want to do some cross-chain experience. And when you need to do cross-chain experience, you introduce the off-chain component. So some off-chain workers or Oracle or the network, some service has to monitor one chain, see what happens on the chain, some events, and trigger activities on another chain. Like when you, for example, transfer an NFT from one chain to another, you need to burn it on one chain and mint it on another chain. So this should be done by some off-chain actor. Also, a lot of exploration in this space, in the off-chain space, comes from the DAOs and governance, like voting, where you pay gas for every vote is not always useful. So like it's really cool to have the off-chain peer-to-peer governance protocols, and like all kinds of interoperability and communication between different applications. It also requires some ability to run computations peer-to-peer. And from web to world, we see just a big topic about anti-centralization, coming from like privacy issues and general movement from Facebook and like people trying to find more like social networks and services which provide better data ownership. So a lot of innovation can be done here with peer-to-peer computing platform. It could be like new generations of applications like messengers and social networks, collaboration applications, and things like that. Like in also there are just technical issues with Web 2. We see these outages happening like once a year at least, like a big outages in a big infrastructure. And we will be seeing them more just because like this infrastructure is too much depend on very small amount of centralized pieces. And not only just technical outages. It's also the big topic is deplatforming. Deplatforming from application, like when basically administrators deplatform users from some applications, so like from social networks, but also this term relevant to deplatforming developers from APIs. Like and we saw these stories with Twitter, with few other big platforms who opened their APIs for other developers to build applications on top of their platforms. So basically people invested time and resources and money into building their businesses on top of the data layers that were provided by social networks. And then these social networks just cut them off when they decided that these applications were not beneficial anymore for the social networks. They just cut the access off, and basically all these people lost their business. And this ability to, when you're opening access to your data, but you can like control all the businesses built on top of this data, like control their liveness and their future. It's just like the barrier that doesn't allow internet to evolve quickly and doesn't allow people to feel safer when they integrate with other services. It's like if you think of how blockchains work on blockchains, because the smart contracts being run by nodes, and nodes are different people from developers who create the smart contracts. It actually creates the great model where you have separated authorship from ownership, where if the code is being deployed into blockchain network, it will be there forever, basically. And because it's there forever, it's safe to build on something that already deployed into network. That's why we see this composability in DeFi, like people building lending protocols on top of stable coins, and then people build like other AMMs on top of lending protocols and things like that. So you can stack the smart contracts safely without fear of access being taken off by the admin of one of the underlying components. But actually, not everything is so cool in Web3. Like theoretically, it's all should work. Practically, we have several issues. First issue is we have elephants in the room. You have like a huge private companies who aggregating users and data, and they are like not open source. They are privately owned. They are centralized. They fully control everything. So it's basically like Web2 companies in crypto. But most of companies in this space trying to build their business kind of in a more decentralized fashion in terms of like value proposition and in terms of infrastructure as well. The problem is a lot of applications just not possible to be built in a decentralized fashion. Like a lot of projects that build value on top of on-chain data, they provide some indexers for some data, like some databases of NFTs, some APIs on top of DeFi data. They just not being able to make it all on-chain. Like they have to introduce off-chain components that take data from the chain, like transform it, somehow aggregate it, index it, and then they provide traditional Web2 API to this data for developers. And then developers build applications on top of this data, on top of these APIs. And basically, for these developers, they are not talking to chain directly. They're talking to these private APIs. And it means that we again have the same composability problem in Web3 that we had in Web2. So these companies basically seek for solutions that would allow them to stay with Web3 in a kind of infrastructurally be at the same Web3 level of the decentralization. So this is where they look for infrastructure that would allow them to create these off-chain components, but not really host them on Amazon. So the way we see peer-to-peer computing is it's something in the middle between cloud centralized computing and the on-chain computing where smart contracts sit. So peer-to-peer computing is something that doesn't really require mandatory consensus on all the computations in the network, but it could allow optional consensus for some pieces of computations. But like compared to the cloud, it doesn't really have the single point of failure or single middleman, single point of control. And again, like some examples of applications that would benefit from being on this peer-to-peer computing platform. It's like all the off-chain components that you can think of, like Oracle indexers, like cross-chain examples, relayers, and things like that. And from like Web2 perspective, it's again social media, messenger, and so on. This is what we built at Fluence. And if you think of Fluence, it's like mainly three big components. It's a programming language called Aqua that we created that allows really easily at highest level of abstraction to create peer-to-peer systems and protocols. It's a network that hosts Aqua and it allows to run applications on it. And it's the economics model around this. Just quickly about the development stack, about the technology. So Aqua is something like, you can think of this as a programming language that you describe programmable requests on. It's like you saying, I want this data piece to go to the network and then to discover some node responsible for this particular function execution and then trigger the function execution on this node and then get a result and send it to the next function and send it to the client. And it's all integrated with, its call could talk to external systems like blockchain, storage, Web2 systems, or could be completely isolated. So it could be just like my browser and your browser, like my device or your device, and we can use Aqua to express the communication between our devices. So like traditionally, this is just some picture of how traditional centralized architecture of the application works. Like you have the backend in the cloud, and usually you have the API gateway, some centralization coordination point that coordinates the backend microservices and things like that. And Aqua just eliminates this centralized coordination piece, and it's basically the Aqua script itself says the network where it should be sent and what it should trigger, and it would be just directly sent from node to node without back and forth to the coordination place. And the language is very easy. So like it's a example of Hello World application that basically says, hey, remote peer, could you say hello back to me? So you can basically trigger the computation on the remote peers and return data back to you. And this language can be used to create network protocols, basically. And if you think of like as we basically having this peer-to-peer infrastructure, we basically transition from having centralized APIs to everything as network protocols. Like you can have file management as a protocol. You can have messages or like a message queue as a protocol. You can have databases, consensus engines, and things like that as a protocol. And it's pluggable to external systems. So like if you need to access data from the blockchain, you need to discover a node that has a specific piece of code that can read blockchain data. Or like you can discover the node on a network that also has the Ethereum blockchain node. And basically all of this, distributed components become really language libraries, which makes really easy to create really complex systems, like distributed systems that could take months or years to create. And it allows to compose really easily in a single language environment. The next thing is the network, and the network is basically the sort of marketplace of nodes where every node is different. It's not like blockchain where every node is the same and has the same data. Here, every node can choose whatever application backends, whatever application components they use or they host, and there can be discoverable and serve together, like together serve applications. And there is no global consensus. There is no ability there is no requirement for all of these nodes to have mandatory consensus on some computations. And again, this is quickly about idea of this decoupling authorship from ownership. It's about compared to a centralized model where application developer basically pays money for hosting their application. And this way they control the backends of the applications, and they control the availability of the application for users. Now, if we say that application backends now hosted by marketplace of nodes, by nodes that independent from developers, it means that if, for example, developer creates the new version of the application and deploys to the network may not agree with developer about this version. So if this version, lacks some features or cuts off some dependency, some nodes may not update. So there will be two versions of this application. And it's basically how blockchains work. Here, it's this logic of this blockchain governance is applicable to wider set of applications. And it also allows to, because we decouple authorship from ownership, it's basically becomes super easy and super safe to build on top of other applications. Let's say if someone created simple component like a chat, for example, component, which runs on some nodes in the network, I am as a developer, I know that it will be there until there is a demand for it, because like for nodes, it's economically makes sense to host it if there is a demand, and there is no developer that can shut down it. So I can just build another component which would use that first component as sort of remote API, and I can build it easier and faster instead of rebuilding chat logic myself. So basically, applications can just evolve quicker because they can compose, because developers can compose pieces and build on top of each other without fear of being cut off. And there's just like examples that we can, take the same pieces of applications and package them differently into different applications. And the last thing is basically the economics that we can have on top of it. And there is a lot of cool things that can be done in terms of the economics. When you move the application execution into the decentralized network instead of centralized cloud, instead of like centralized companies, it basically means that now you can, for example, govern applications by DAOs. Like not only on-chain smart contract governed by DAOs, but like really, like if you have the messenger app, or you have the social network, or you have like the other off-chain application, you can govern it via DAO, because the DAO may pay for hosting. Like the DAO may pay in crypto for hosting on the network nodes. And this is pretty cool. This just allows like enables a lot of opportunities and innovation about how applications managed and created on the internet. DAOs, like it's much easier to fundraise if you're creating DAO than traditional company, things like that. Also, another cool thing is potentially such platform would allow open source monetization. It's like if you're right now in the Web2 world, if you created some useful open source component, you have only traditional ways to monetize it. Like you can have open core models, so you can get paid for consulting, or you can try, like if it's, for example, database, you can try to compete with Amazon by setting up your own cloud, but it's really hard to earn a lot of money out of it, because if your database is provided in Amazon or in like Microsoft Cloud, but as a service, it's basically hard to compete with them because they have so huge ecosystem with all other components and services easily integratable with each other. So, but if they provide your popular database as a service, they're not paying you as an author anything. They just earn a lot of money. Like they earn a lot of money from MySQL, like MariaDB as a service, and they just not paying authors anything back. And Fluence changes it, because now if you create some useful component of the application like database, and it's being used across many applications on the Fluence network by many, used by many applications, and developers pay a lot of money to nodes for hosting these components as a part of their applications. Now, fraction of this revenue stream can go to author of the component, the author of database, because it's all happens on a decentralized network. It's basically like happens on chain. It's transparent, and it could be like as a rule of the transaction, the rule of the contracts on the network is to pay share to the author of the component, and this is what's not really possible in a Web2 model. So this is pretty cool, and there are just a lot of opportunities. Just DeFi on top of computation pieces, like all kinds of computation deals, discounts offering like derivatives and different workloads, things like that. So there could be a lot of cool markets that not exist for now, really. Like there is a sort of internal market of the computation workloads in the Amazon, for example, because they're huge. They can manually offer you cheaper computation if they have underloaded machines or things like that. But now it could be like really automated, really like on-chain, really serve as a real market, not just some internal company processes. So currently we are at stage that the Aqua language and the network is live and running. We have applications there, nodes, like people experimenting, building stuff. We are now really close to launching the Fluence Network DAO and the governance model. It will be on-chain token and on-chain voting for proposals and treasury allocations. And we are targeting enabling the economics and the payments of the network. So the actual status of the network, like you can see at --fluence.dev, it's basically network dashboard with some services, nodes, and things that deploy it into network. That's it for now, I guess. Yeah, we are hiring, and this is our community channels. So yeah, thank you. I think that's all I have for now. Maybe if there are some questions.
There definitely are. Thank you for the presentation. Let's see. First of all, it's quite an undertaking to support as many, as you say, protocols agnostically, to be able to interact with them via one system. So kudos for that first. Yeah.
Thank you.
Yes, especially with like you explained with Aqua, it provides a form of standardization between these different networks. I'm wondering, I saw that there were, you mentioned the slide with network algorithms as libraries with different types of protocols supported. So
yep.
if I host a project and I want to plug in my own project as part of these, for instance, how would I go about that? For instance, let's say I want to see you also offer file management. Let's say I want to insert Swarm.
Yeah. So basically, in Fluence, you have this two pieces. Like there is Aqua, which is language that you use to express peer-to-peer workflows and network communication. And there is a Marine. It's a WebAssembly runtime that's basically runs code on nodes. It's sort of like the computation runtime that you deploy to nodes and you can execute there. So basically use Aqua to trigger Marine code. And then with Marine, you can build, like you can access external resources. You can access node file system. You can access like use HTTP or other ways of communication to access external stuff. So in order to connect new external thing to Fluence network, you need to write the piece of code called adapter, and that would basically map Aqua to the external interface. So like if you would like to plug Swarm, it should be like really easy. Like it depends on what interface Swarm node provides, but you can either connect it via this adapter over the network, or you can have the Swarm binary on the same node where a Fluence node sits, and you will have the adapter that talks to Swarm binary over this node file system. But like in general, these pieces of code, like these adapters are not really hard to build.
Then I can file them to the repo where they're collected, and then the next update system will understand, oh wait, we now support Swarm as well, or how would that work?
The way how it works, like every application decides whatever integrations they need, right? So like if I need Ethereum integration, basically when I develop my application on top of Fluence, I take I need to compile these Marine services from the modules, which are WebAssembly codes, which are WebAssembly modules. And I would just include like the Ethereum adapter into my Marine service, and just as a part of my application. And Fluence node will support it when it will be deployed there. So if I need to use Swarm, what I need really to do is to get this Swarm adapter as a part of my application and deploy it to Fluence node. But like, I mean, this would work if I don't need to have Swarm installed on the node. But if I need to Swarm like a Swarm node installed on the same machine where a Fluence node is, and if I need that, then it's basically a little different routine. Like I have either choice to only deploy to nodes that I control. So I would deploy Swarm node instances to these machines. And then I would deploy Fluence nodes to these machines, and then I would deploy applications inside Fluence. So my application would only run on the machines that have Swarm node and Fluence node. Or I will be able to, like, this is where we sort of come in, I will be able to discover on Fluence network, like nodes will be able to advertise whatever external services that they can provide, because like some nodes can already have Swarm node software installed there, and some others may have like, I don't know, like IPFS software, right? So, and I want to, with my application, with my Aqua script, I want to say, I want to discover whoever node provides access to Swarm and, send this data piece there and, put it into the network or get it from the network and do something with that. So I will be able to discover these nodes that provide integrations. But like currently, there are basically two ways. Adapter that access Swarm node over the network, or my own nodes that have Swarm node software that are installed.
Okay. And there was a question about oracles. Does Fluence support oracles?
Yeah, so Fluence is basically an oracle. It's like, what is oracle? Oracle is like basically off-chain components that bring some data on-chain, right? So Fluence is the infrastructure that you can use to build oracles. You can have the, with Fluence, you can have the adapter to on-chain, like to some, let's say to Ethereum. So you can read whatever happens on-chain from the Fluence network, and you can generate transaction and send it to Ethereum network when something happens. So you can build the oracle logic on Fluence. And it could be just the like single worker that looks at the chain events and then queries Web2 APIs and provides data, for example, right? Or you can make it more complex. You can say that on Fluence, I want to have several workers, and I want to require them to have consensus on top of what data they want to send to the network, because I can use Aqua to write this consensus algorithm. So I can, like basic consensus algorithm is like, I want to have several workers on Fluence network to execute the same code and then exchange signatures that they agree on the result of this code. So basically, at the result I would get the execution result plus several signatures from many nodes, and then I would take this blob of data and send it on chain to smart contract, and smart contract will see that this data was verified by several nodes in Fluence network, and it's basically the oracle functionality. So in this, like, I mean, in these terms, Fluence doesn't provide you as complete or like as complete oracle solution as, for example, like Chainlink or something else. You can kind of like, you need to kind of build the oracle on Fluence, but you have much more flexibility in terms of security model and external data and like and the business logic here.
How does this go in parallel with what you mentioned, that there was no mandatory consensus for the network?
Yeah, so there is no mandatory consensus, but you can write the code that would implement consensus. Like we have some examples, for example, in our documentation. It's basically like you write in AquaScript that you either like it's basically you write an Aqua script and deploy it to the Fluence node, and then say that you want this Aqua script to be executed. For example, we call it scheduled script, like executed, like let's say like once per minute. So this script could do the following. The script could look at the chain, see some event, some target event happened there, then receive this data from the chain, then do some computation, so generate the new piece of data, and then send it to all nodes that they know are part of this Oracle protocol. And every node on this Oracle protocol would do the same, and they will then basically, by exchanging this piece of data, that they would collect a list of signatures on this piece of data. So this will be sort of the basic consensus. But also, like if you want to implement Raft, it's also possible, for example, to implement Raft consensus, so like a BFT consensus, more comprehensive consensus algorithm on Aqua. Yeah, so if anyone interested in implementing, more comprehensive consensus, we're always happy to talk about this, because it's one of the components that we envision to be built on the network and being reused by other applications.
You want to be able to insert that one as well, like if you have any implementation, you would, what be preferred, for instance, Tendermint or another.
Well, I mean, like there could be different. We now like open to see any experimentation in this direction. Like, I mean, even like simplest, probably, I'm not sure, Raft, like probably Raft would be simpler. So even if Raft, it's still very useful for many distributed systems.
Okay. About the data you mentioned, the question was, are there any limitations on the size of the data that can be sent over the network?
So if you want to send, files over the network, it's probably not would be a good idea to send them like directly through Aqua. The way how you would want to do is basically, like for example, you want to build some peer-to-peer data sharing application, right? So, and you have Fluence peers in two browsers, like on two devices. The best way to implement it is to use like Swarm, for example, as a like a data storage, like a one Swarm node or several Swarm nodes in the middle between these two peers. So basically, like you would say that this peer, peer one, uploads data, like discovers the Swarm node over the Fluence network, then uploads data into Swarm node, and then peer two downloads data from the Swarm node. And usually, like in when you start doing this, there are certain things that can be like that really make this use case a little more complex than it seems to be. Like for example, when we were experimenting with IPFS file sharing, there was problem that the data was not propagating quickly on our IPFS network. So if one peer uploading data to one IPFS node and then another peer connected to another IPFS node, after the data is uploaded, second peer could not be able to download the data because the second IPFS node didn't know where the data is. So you could use Fluence to basically say that after uploading data into IPFS, we're sending the data ID and the peer and the IPFS peer ID to the second peer over Fluence network. So basically, you had kind of like two networks: IPFS network transferring data, but slowly, and then Fluence network transferring data discovery, like metadata, basically about that allowed to discover where this data piece sits over Fluence network. So like something similar also can be done with using Swarm, but it depends on use cases.
This actually ties into another question, because if you're talking discovery, it depends. Okay, are you talking discovery on the Fluence nodes or with the rest of the network, of course, where it's up, or the requests are being sent. The question is, where are scripts executed? On a node that it was deployed to, or on many nodes?
Yeah. So yeah. So Marine is this WebAssembly runtime is basically the something similar to microservices. So like it's a piece of code that you compile somewhere like locally as a developer, and then you deploy it somewhere on some node, and it sits there. So you can you know that it's being deployed on this node, so you can call it from this particular node. Then, but you can like also deploy it to many nodes if you want. Then there is Aqua, and Aqua is something that there is Aqua virtual machine on every Fluence node. So Aqua script, when it's executed, it basically describes itself where it should go and what it should do next. So it could say when it's like when you execute Aqua script, let's say on a device, it could say, okay, I'm taking this local piece of data, but now I need to discover some node that has a swarm and transfer this piece of data together with this Aqua script to this node, and then execute the function swarm.put on this remote node, and then get a result from the swarm node, and also then take this result together with the Aqua script and send it to, like further to the next step of the execution. So basically, Aqua scripts, they travel over the network together with a piece of data. So they're not sitting in a particular place. They're sort of traveling as a request.
Yeah, and then execute where they are sent to.
Yeah,
exactly. Locally. We just had a presentation previously by Anatol on the ultralight mode of Swarm. If you want to run a node in an ultralight way. Are there any ideas for Fluence in different types of modes as well, for different services you'd like to offer for different devices?
I guess maybe we are not at this moment yet. Like we are basically at Fluence, you have this more full-featured node that can run Marine right now, and it's only backend nodes can run Marine right now. And there is like a browser-based Fluence client that cannot run WebAssembly Marine services right now. But what we are working on is it's called Marine Web, which would allow also to run this Marine WebAssembly-based services into browser as well. So actually, we are sort of moving from having two different types of nodes, like a full node, more complete backend node, and the thinner browser peer, into more sort of parity and more like homogeneous network. So backend nodes and the device nodes, it's sort of similar, like more similar than they were before. But I mean, I understand the potential negative consequences of this also. So we are sort of like in exploration phase, in terms of what should be the best design here, and what types of nodes could we need in the future.
For the viewers, again, if you have any further questions, please ask them via Discord, the Fair Data Society Discord of the WAM event, where we are currently being looked, where we check for questions. And I had another one which came in, and that's related to this actually. And you mentioned in your overview of the roadmap, you're working towards a DAO as well as a structure.
Yep.
And my question was, okay, if I host a Fluence node, it connects with different networks, it can run an application, and the author is compensating for this? Because I was wondering about the incentive model for node operators here.
Yeah, so this is the part of the future economics model. We will have the system that is like basically there will be on-chain deals or like contracts between developers and node operators about hosting this particular piece of data or this particular piece of code for some period of time with some, limitations in terms of requests and things like that. So it's not there yet. So there is no way to pay right now, but that's something that is coming in the future. So the nodes will be able to earn money by providing their capacity to the network.
Okay. See, some actually requesting. Let's see, are all nodes orchestrators, or are there guardian nodes? One of the questions.
So what was the question?
The question is, are all nodes orchestrators? Are there types like guardian nodes? And is there, quotes, slashing involved?
Okay, I see. So there is no slashing because if there is no mandatory verification, then there could not be slashing. It's like for what you want to slash the nodes, right? Like you maybe want to slash the nodes for incorrect computation, but then the question is like, how do you verify the computation? How do you prove that some node doesn't provide the correct result and things like that? So again, like in general on Fluence, there is no computation verification by default, but you can enable it for a piece of your application by incorporating consensus. Or we envision also like different like other ways of verifying computations, or like using trusted execution environments on particular nodes. Like you want to say, I want to deploy this piece of code only on nodes that have TEE, for example, right? But this is something that comes in the future. And yeah, so like I guess if we talk about like guardians and things like that, this is related to like economics of the like punishment or verification. So it's not part of the model right now.
As in, there's no reputation model built in.
So on reputation, there is what we have is we call it trust graph. So, and trust graph is basically something similar to web of trust model. So there is a distributed database on the network with relationships between nodes and developers, like and other actors of the network. And it's basically useful, like it's being used in Fluence node software to avoid cyber attacks. Just like technically, it's connection pool is being split to peers known by trust graph and unknown peers. So there's always some connection pool capacity for known peers and unknown peers. So like if only
like
unknown. Yeah, like it's the thing is like it's if someone creates like 1 million Sybil nodes and fills all the connection pool to some node, we are Sybil nodes, this node will be disconnected from real network. But now if we have to these allocations, every node will always be able to connect to some nodes they know, and also every node will be able to keep some part of connection pool open for new connections to always be like have some optimal connectivity to the rest of network. So and the way how trust graph works is kind of like similarly to how certificate authorities in a web works. Like you have a list of root certificates in your operating system, and then you go to the website with SSL certificate, and then they provide you a certificate which is signed by authority which key you have in your operating system. So you can verify that their certificate is correct and you can trust them. So on Fluence network, every node has the list of keys that they trust, and these keys may issue trust to other keys, and these keys issue trust to other keys. So basically you have this graph of the trust where and then when you discover some nodes on the network, you can basically see, given the list of keys that you have locally, do you know this node, and can you trust this node, and how can you trust this node, with what sort of degree, with what weight of trust you can do it. So and this basically sort of reputation system, because it allows you to say, if I'm a developer, I trust to nodes that related to node provider called Amazon. So I want to program that my code will only be executed on the nodes that related to Amazon or like trusted by Amazon. So I can basically only execute on nodes that I trust transitively or directly. So I can manage this. So I can leverage this reputation system this way.
Yeah. Let's see. We are nearing the next talk. There are two things I wanted to ask you. It's first of all, your colleague Anna shared with us a video of a workshop on how to set up your own node from ETH Denver. Is that the most recent one you'd like us to share?
Yeah, I think that would be a good one. Yeah, that's pretty fresh.
Well, we'll make sure it's shared in the Discord to all our participants right now. Well, one of the audience members, I already basically only asked this, how do we insert Swarm? One of the audience members is asking, are there any plans to support Swarm from you?
Yeah, for sure. I mean, we are like, Fluence is trying to be like really, connected to other protocols. So like, if people want to use Fluence with Swarm, it basically means that we only need to build this adapter to provide Swarm integration. So that's just like, the question only how fast we can do it in terms of, backlog and things like that. Or like, if any community members can get involved, like even like during this hackathon and build that's integration, that would be like amazing, I think, because it could be like immediately reusable by other people. So we are like very open to Swarm integration for sure.
Was this included in your bounties as well?
Actually, I need to check. But
if not, we'll see what we can do.
Yeah, let's just agree that it's included.
Yes. For those who don't know, Fluence has sponsored the We Are Millions Hackathon with a list of bounties for the challenges participants. So thank you for that as well.
Thank you.
And thank you for this presentation and all the time you took for the questions from the audience. I hope to see you, and as I already saw Anna responding in chat for the questions. I would like to take it to the next presentation. Thanks again, and I'd like to call upon Stefan Ponnet from Avado, if he's available.
Yes, hello, can you hear me?
Hi, loud and clear, coming through. And for anyone watching, in case you're looking at the program, there was some delay, so we decided to switch up the program, and session from Avado, which was at 7:30 CET, is now, and the session from NIM is after this one. So we'll first start off with Avado. And Stefan will go with us on a deep dive on how to run a Swarm data node, as far as I understood.
Yeah, sure. So I'm gonna explain some background on Avado, so where we're coming from, and why and how we are supporting Swarm in this. So let me try to share my screen here.
I will pick up any questions from Discord. Let's discuss them at the end.
Okay, very well. Can you see my screen?
Yeah.
Okay, perfect. So yeah, just a few words about myself. So my name is Stefan Ponnet. I'm the co-founder of Avado and also the technical lead of the team. And I've been doing crypto since 2015 full time. So I've been around quite some years. So let me first, for those who don't know, Avado, explain what exactly we are doing. So since 2018, we are selling these devices. These are what we call plug-and-play blockchain nodes. So that means they are headless. So they just look like your router, and you also plug them into your router. And it comes with a web interface and also Wi-Fi access to set it up. The goal of Avado is that people that run an Avado at home, that they can get access to all kinds of dApps and all kinds of like insurgent platforms through what we call a dApp store. So we are assembling and compiling a whole list of dApps that you can run on the hardware at home. And we try to make that as convenient as possible for everybody. So we have what we call a no CLI approach. So a lot of that software is pretty sort of tedious to run or to set up, certainly if you're not so tech savvy. That's why we try to make everything accessible through a graphical user interface. So our mantra is to say the user never has to touch the CLI to set up his computing nodes. So maybe just a little bit of background on how we see Avado fit in the whole history of computing. So there were like every 10 to 15 years, you see that there's like new types of computing models that arise. So it started with the mainframes, then personal computers, then about 10 years later, the insurgence of the internet, then the whole mobile web evolution. And then, so we see that each 10 or 15 years, there's this new computing platforms that enable new classes of applications that didn't exist before to emerge. Now, if you look at the blockchain era, so we see that from approximately 2010 onwards, we had the concept of blockchain, which sort of democratization of the exchange of value was started back then. But then again, like fast forward 10 years, we see that there's like a whole new era of dApps and also layer 2 solutions that are coming in the form of DEXs, sidechains, bridges, and so forth. But also new peer-to-peer protocols that pop up, like, for example, Swarm or IPFS, Hopper, Tornado Cash, and all kinds of applications that also include token incentives. And that's what makes it interesting, of course. Now, for those who might ask why exactly a blockchain node, what kind of pain do we solve? So we are saying that the Avado hardware is sort of the equivalent of not your keys, not your coins, for servers in the new Web3 era. So for people that, like I said, that are not so tech savvy, if they want to participate, they don't exactly know how to start. So how can I start and participate in a proof of stake network, for example? That's pretty technically to set this up. How can I contribute to my favorite dApp? So if you're already involved for some time in a certain community and you want to support a network, typically they ask you to run a node, but how do you get started? How do you do that? And thirdly, and which is also very important for people that run Avados in our community, is how can I benefit from this participation? So we saw a number of observations through 2018 until now. Is that first of all, people, they don't want to spend too much time researching hardware. So that's why we created our own hardware. So the box that you see here is how the Avado looks. So it's a fanless design, so it means it's completely silent, so it doesn't interrupt, let's say, the quietness in your living room. It also has a recognizable form factor. It just looks like a router. It's also not much bigger than a regular router. And it also comes in different hardware specifications. So we have like options starting at 2 terabytes to 8 terabytes of disk space that it comes with, and 32 to 64 gigabytes of RAM. Second observation that we saw is that users are usually not inclined to read manuals. So what we did for all the software packages that we support is that we created much more easy to consume content, like YouTube explainer, unboxing videos, how to hook up your Avado and get it set up, different walkthroughs. For example, if you want to generate staking keys, if you want to run Ethereum 2 on your Avado. So that's all possible, and in a very convenient format. And then thirdly, as I already explained in the beginning, that users are scared of the CLI. So we create onboarding wizards for each of these packages. So whenever the software that we want to add doesn't come with an interface, because some of them obviously already come with some form of a web UI, for example, like the Swarm package. If that doesn't exist, then we build it ourselves. So we integrate. So the example that I show here is for staking on Avalanche, for example. Then we show like a node status. You need then that node ID to perform other functions, a backup and restore functionality for these, for all the keys that he generates and so forth. So that's very important for us, that people don't have to touch the CLI for that. And that's also one of the things that we hear and see from people in our community, that they value that a lot. And that is usually one of the reasons why they go for Avado. And then as last point, the users, they want you to hold their hands. So because we have a standardization in the hardware and also a standardization in the software, means that every user that comes is new to Avado experiences exactly the same thing. So that makes it very easy for other people in the community to help out each other, because the discussion is never about does this driver work on your hardware, or how much memory do I have to put in, or this or that. So people, they can see other people being successful by running and setting up their Avado. So it's very convenient for them to say like, I will manage too, if all these other people already know how to do it. And since it's like standardized both on the hardware and the software side, it's very easy for other people to give support to each other. So we have basically an always on support system to the different Telegram channels that we have. And we hear, and it's hard for me to say that, of course, but if we listen at feedback from our community, they all say it's very welcoming. And so they get help very quickly when they are new to Avado. So if we take a look at the Avado use case, so there are basically three main categories currently where we are active in. First one is staking. Then the second one is sharing your Avado resources. And then the third one is also sharing your resources, but then for third-party apps. And that's sort of the category where Swarm falls into. So if you take a look at staking, so these are the networks that we currently support. So you can do ETH2 staking, you can stake on Avalanche or Quotum. You can also stake on Ethereum through Rocket Pool and also be a validator on the Gnosis chain. The big difference between running your own staking nodes versus participating in staking through an exchange, for example, is that with the Avado, since you are running everything yourself, you're also keeping all the rewards yourself. And if you look at exchanges, they sometimes take fees going to 15, sometimes 20% or more from the staking rewards that you should or would earn otherwise. And so Avado is one avenue where you can do that by yourself, and you don't have to share your profits with anybody else. And this is the main reason currently why people are buying this box, because they say, yeah, it's just a one-time investment to buy the hardware. But then year after year or month after month, I get all the rewards and don't have to share them with a third party. And of course, it's also better for the whole concept of decentralization for running the node yourself. Then secondly, you can also share your Avado native resources. So since you're getting a whole computing platform in your own home, there are a lot of services that natively run on the Avado that you can share. And we create the concept of the Avado Rio Cloud with the acronym for Run Your Own. So you can literally create your own clouds there, and you can share resources like your IPFS node or your Ethereum nodes, or even if you would run a beacon chain, you can also share those things. And we created sort of a load balancer on top of that. So here, for example, that Ethereum RPC pool is something that you can access, and it's always backed by dozens of Avado runners. So basically, we have a whole sort of mini Infura style service that runs there. Currently, it's all free to use, so people can just make use of that service. We are currently also implementing a reward model for that, so that people that actually run their nodes, then they can also get rewarded. But this is still a work in progress. Then the third part is the sharing of your own resources through third-party apps. So it can be related to storage or bandwidth or CPU, so the three assets that you get with your Avado. So some examples of applications that we support today are Hopper, which is a sort of a decentralized messaging protocol. We also have Mysterium Network, which is a decentralized VPN, so that your Avado basically becomes an endpoint for a decentralized VPN network, and you get compensated in their tokens to run that. And then, of course, we have the Swarm node itself. And this brings me to Swarm itself. So I don't have a live demo of this package, but I took some screenshots just to give you an idea on how it works. So what you're currently seeing is the web interface of the Avado. And in the dApp directory that we have, which is that whole collection of packages that you can run. So we have released the Swarm node. So it's there in the corner. If you want to install it, you can click on the detail button. And then you get some generic information about what it is and what is interesting for you to run it. And if you want to install it, it's as simple as just clicking the install button. And then it's in the background, it installs the node. The data for the node currently is hosted on IPFS, so it's also not depending on us to be distributed and downloaded by your node. And once you run it, so here, of course, the user interface, the onboarding that we had to create was very minimalistic because there's something like the Swarm dashboards, which we also included. So that means if you run the package, it doesn't only run the Swarm node itself, so the B node as a software, but also includes the local version of the Swarm dashboard, which then connects to your own node. And so if you click on that button, then you will open a second tab in which you can see the Swarm dashboard, and there you can do all the actions that you can, like manage your files, do the things with the stamps and so forth. So you can do all that stuff from the integrated dashboards. So what you get in the end is a system where the Avado, together with the Swarm package, on the one hand side to the internet, it connects to the peer-to-peer network and participates in the strength of the network. And on the other hand, you also get your own private endpoints for both the UI. So if you go to b.my.avado.do, whenever you're connected to that machine, then you can access and manage your own nodes. But you also get the API. So if you want to extend the functionalities and start writing more applications that integrate with Swarm, you can also build those packages yourself and have them talk to your own local Swarm node. So that is also the purpose which I'm explaining here for the Avado SDK. So you can extend the whole system with the SDK, so it's just freely available. It allows you to create new packages and then also use all these Avado, these available resources. So for example, the Swarm node endpoints. This whole system is based on Docker, so we're following all the industry standards there, since most of the software packages and all the projects usually support Docker in the sense that they also provide a Docker image of their software. It is actually pretty easy to get something new running on the Avado platform. So that's also something that we can support here. Now, how we see the future for Swarm or Swarm package on Avado is, first of all, look closely or monitor closely the incentivization structure. And so for us, the goal is to answer the question, how can we earn as an Avado node runner? So either by actively using the protocol, but also maybe just as a passive node runner. If you say, I just want to run a node and earn something from it in the form of passive income, how can we do that? A second opportunity that we want to look to in the future is, can we make a customized box for Swarm node runners? On the right-hand side, I put sort of the price list, which is published on our website of these nodes. As you can see, they're not very cheap. That's because they are very powerful. So they have a very modern CPU, a lot of storage, which is very expensive, and also a lot of RAM integrated into that. Now, maybe for specific people that want to run only Swarm at home, we could also create a customized box with like a different configuration. Maybe it doesn't need a large disk like that, or maybe it doesn't have that much CPU specifications or so. And then we can also make the right price for a dedicated node. So we might look into that into the future. And also to support the ecosystem, we would also like to onboard more apps that are being built on top of Swarm. Because like I explained before, it's very easy to run something and then have it talk to your own local node. So these were the things I would like to say. So I'm not going to take too much of your time here in this nice session. So if you want to check us out, I left here the links to the website. You can also follow us on Twitter. So every time that if we publish new packages or package updates, we notify people through that. And also feel free to join us on the Telegram. So if there are any questions or remarks, I would like to hear them. Thank you.
Thank you, Stefan. There definitely are. I already saw a few coming in. Thank you for your presentation first. And you're the first hardware project we've seen in this event for the past weeks. So that's already well, first, yeah. My question would be, if I made a project, and I asked the same thing actually at the Fluence, how do I add or implement or ask for an integration of my own project if I want to be part of the Avado package which is being offered? So if let's say I want to offer my own staking node.
Yeah. So I think first of all you will go to the Avado SDK and like try to wrap if you already have something like a Docker container, you can wrap it through the SDK. And you can either distribute it yourself, because since we upload everything to IPFS in our case, it results, if you build the package, it will result into an IPFS hash, which you can just distribute to people, and they can, based on the IPFS hash, already install it. Or you can also ask us to integrate it into the dApp store. So we have a couple of partnerships with other projects that have built and are maintaining their own Avado version of their software. And then whenever they issue like a pull request on their repo, we include it and we update the version in our store. But I don't know if that answers your question.
Actually, yes. It's where do I go to as a developer to be integrated? So, yeah. I would start. Of course, you got lots of documentation, which you linked to on the last slide as well.
Yeah.
One of the questions was, what would you consider one of the main challenges for a wider adoption of Avado?
Yeah, so I think the sort of that convenience which we are trying to bring to the markets is actually a very difficult thing as well to sell, because for example, an exchange makes it super easy. If you just have a small balance on an exchange, you can start staking it and they will take care of everything. There's a lot of limitations that aren't there on an exchange. If you want to stake Ethereum, for example, you need to have either 16 if you go with Rocket Pool, or the full 32 ETH. Which is not is not easy for anybody to participate in that. But on the other hand, there's the whole idea about decentralization is sort of partly nullified by that, because if everybody would start staking on an exchange, then it's all again centralized. And if you look at the client diversity, for example, on Ethereum 2, the main reason why there's such a big majority of stakers running on the Prism implementation is just because a couple of large exchanges do the staking for their clients on these platforms. So what makes it difficult for us to sell is like we have to challenge that that convenience, that user convenience, and that is actually pretty hard to do. But like I said, we're trying to do our best to sort of implement that with all these user interfaces and these wizards that we create on our platform. And thereby making it as convenient as possible for people. So, and of course, I think the benefit that we have is that once people invest in buying a hardware device, then they can like keep all the profits of their staking, for example. And then on top of that, we have like a number of other applications, like Swarm, for example, where there is a possibility to actually earn something back just for running a node as well. So that's sort of the how do you say that, the icing on the cake, that you can have some passive income running those apps. Yeah.
You mentioned the tiers. You showed the different types of devices currently being offered. So you got staking, the resource sharing for Avado and for third parties. What's the, if you have to give like a broad estimate for a beginner, what is the return on investment time if you were to invest and buy an Avado node? Aside from, of course, the individual, let's say, benefits, but I'm just talking with investment-wise.
Yeah, it largely depends on the use case, of course. But like one example is staking, which is one of those things that we that a lot of people in our community do. If you are staking on Ethereum, for example, then the time to earn back the initial investment is about 4 months. So it's not very long. But if you have to do the comparison honestly, then you have to compare that to what is the difference whether if I already have 32 ETH, if I stake it on an exchange or if I stake it on an Avado myself. And there you see, because then it's only that like that difference, that margin that your exchange would take, which is sort of the offsetting price there. And then you're looking at about 13 months or so. So if that's really, if you're planning on staking something like 32 ETH more than, let's say, 1 year, then it's more profitable in any case to buy your own hardware and just to run it yourself, because you just earn all the fees yourself. Now, an important side note, of course, is that it's not like, I'm just investing like for our cheapest model is, for example, $1,600. So I'm just investing this, and then after 4 months, I will have earned that back. No, you also have to have the stake, of course, to participate in the proof of stake system. So it's not like it's some magical money machine or anything like that. It's just something that makes that whole endeavor of staking, it just optimizes it. And we try to make the difference between going for like a super easy solution, like staking on an exchange, and doing it at home, the way it's supposed to be, decentralized, and like running your own node at home, like comparable in user experience to going to an exchange.
No CLI at all.
Yeah, exactly. That's
I like the
logo for us.
Have you, with the feedback from the community, have you seen that I can imagine there's a sweet spot between those who would like full terminal power and those who indeed like what you see, what you get, that's it. And somewhere in there you found the target zone. How has the response been till now?
Yeah, so obviously our audience is more on the side of the, let's say, the less technical savvy audience, but also people that are tech savvy, but that they just say like, for example, setting up a server and like configuring all that software. I mean, been there, done that. I've already done that 100 times. I'm willing to pay the premium for buying that device so that I just save on all that time for setting it up. And also, like a very important aspect, which I haven't mentioned yet, is these the updates of the software. And so since we are always like adding updates of the software into our dApp store, and the operating system itself comes with an auto update feature. That means that if you're like staking on Ethereum in a certain platform, so we support currently Prism and also Teco, which was launched today actually. So these two platforms, they also require updates. So every now and then there's like an update on that version. If you would do everything yourself, you always have to like monitor these GitHub repos, log into these servers, do the updates, also the whole DevOps thing that you normally need to do. And that's also something that we take away so we take that burden away with the automatic updates. So we do that work for you. We update the software, we push it into that dApp store, and then your Avado at home will notice there's like a new version, and in the background it will automatically update and just restart, and then you continue your staking adventure with like the latest version of the software. So that's also like a benefit that you get running our platform versus doing everything yourself.
Could I also do that manually in case I want that for security reasons, for instance?
Yeah, you could, because all the packages that we have and also all the other software, by the way, is also open source. So if you look at our GitHub repo, where the link of the SDK is in my presentation, so you can use that link to also go to the rest of our repos. So you can all build these packages yourself. So the only thing we are doing is we are updating these GitHub repos for example, for the Swarm package. But if you want to verify it yourself, you can just check it out yourself and then use our SDK to build the package again and use that version, and it should result in exactly the same binaries that come out.
Now I understand the appeal for a low maintenance, client-friendly node, to put it that way. I'm wondering, the audience who is interested in staking has at least some part tech savvy to have the understanding of what it can offer and what services it interacts with and what it means. Mm-hmm. Now I'm curious, what kind of hardware are you offering in the boxes you're providing? Just from a perspective of like I mentioned before, either security or support as well.
Yeah. So all the details of the exact hardware also on our website. But so it's basically an Intel. It's an Intel-based platform. So it's like a NUC. You have the Intel NUC, but it's like in a different form factor. But the insights are largely the same. So basically, it's a regular Linux machine as you would buy it or even rent it in a data center. But it's also like as powerful as a server that you would rent in a data center. Obviously, the bandwidth depends on the bandwidth that you have at home. So there's like certain countries in the world that have better connectivity, of course, than others, and have more bandwidth to spare. But other than that, it's a pretty standard. So the host system is just like a Linux system, and then the Avado software are all these like Docker containers that are on top of that, and it's all like orchestration of these updates and so forth is all built into that. So, like I said, it's a pretty pragmatic solution. It's maybe not rocket science, but it just alleviates a lot of these pains for people to run a node. Because what we see in communities often is that people that either have invested in a certain token and are active in that community, at a certain point they say, okay, now there's this opportunity to stake, but how do I need to start? So there's like a certain like group,
technical barrier,
each community that say, we want to do everything ourselves, and we don't even care for decentralization, so let's run it on an AWS server and let's do everything ourselves. But then there are also other people that say, I really want to participate, but I don't really know how. And if, of course, then there's like a solution where you can just like buy a box that almost comes pre-installed with all that software, and the only thing you have to do is like click a few buttons to get it started. If that is your way that you can participate and contribute to the project that you like or the project that you invested in, that opens up like a whole new aspect of people that otherwise would be inactive in your community. Like, inactive in the sense like they are not contributing to your peer-to-peer network. So you're like pulling in more people that are potentially nodes in your network. So I think our vision should be that each decentralized project, each blockchain project on our website, so our hope there is that they at a certain point would say, like, if you visit our website and you're interested in our software, there are like two options that you have. So either you go to our GitHub repo and you start running your node yourself, or there's this like second option that just says buy a box with the software pre-installed. So I mean, those should be the two options. And now by only offering a software download on these projects, a lot of projects are missing out on a lot of potential, we believe.
I agree, because it's the Venn diagrams usually not overlap necessarily. The ones who want to invest in project and the ones who want to build with it. Yeah.
Absolutely.
I have another question, and I see some come in from the Discord chat as well. You've been in the grant program of Swarm. With you, I mean project itself.
Yes.
I gotta ask, what would you say to potential the projects who might think of joining this grant program, and how was it for you guys? No need to sugarcoat it.
So I think we've already participated in a lot of grant programs, because every like software that is interesting for us, I think we have something to offer as well, because right now there's about like close to 2,000 devices that we've sold. So that means that there's like a huge potential. So if we add a new piece of software in our dApp store, that means that from one day to the next, that software is all of a sudden available to that whole community of people that are already running that. And these are people that have already done the investment in the hardware. They all know about decentralization. They know about blockchain. So it's really the right audience to sort of incentivize or like show them a new piece of software that they can run on their box. So that's why we participate in these programs also. So with together now with Swarm. For us, like comparing it to other programs, I think this was a very like easygoing sort of journey together with you guys. I think we also got a lot of support, also a lot of ideas, because in the beginning we also wanted to create our own graphical user interface to really like monitor and do all that stuff with the Swarm node. And then the people from the grant program also mentioned the Swarm dashboard, for example, to us. We didn't know about it until they mentioned it. So that also helped us out a lot. So yeah, I would definitely recommend anybody to join the program, of course. Yeah.
That's good to hear. Yeah. Sorry for putting you on the spot right there, but it was wondering.
Yeah.
And
honest feedback.
Final question would be from the chat: can we buy an Avado with crypto or just with fiat?
Yeah, so we have both options. So we currently support paying through credit card or PayPal, so all the traditional ways of paying. And then also we support DAI as payments. So if you want to pay in crypto, that's not a problem. So we currently only accept DAI, but we accept it on all different networks. So on the Ethereum mainnet and also on all the other side chains that have DAI. So you can just throw any DAI to us in any form, and the price is exactly the same. So on the side of if you pay with your credit card, for example, you have a credit card fee. With crypto, you don't have a fee except the gas cost that you have to pay. So that's we always encourage people to pay in crypto, obviously, but we see that a lot of people certainly sort of the type of people that want to purchase an Avado and want to tap in that convenience and so forth, there's like still a lot of demand for paying just with a regular credit card as well. But it's possible with crypto, certainly.
And with that, I'd like to thank you for your presentation
Yeah,
and for the deep
thanks
dive
for
into Avado.
It's very nice.
If there are any follow-up questions, then please take a look at our Discord at during the event. And of course, we'll see each other again at the next events, perhaps, where Avado will be part of the Swarm ecosystem. So,
Okay, thank you.
thank you.
Take care.
And with that, I would like to continue. First of all, don't forget to claim your experience with your NFT Swarm. So the We Are Millions avatar of the event, of course, for all the participants who are currently watching. Then we have a node workshop, and I'm going to ask our colleague Gasper to start it, which was shared by Nim. There we go.
Hi everyone and welcome. My name is Tommy and I am a QA at NIM. And today I'm going to be giving an overview on how to run a NIM mix node. So first and foremost, I would like to highlight this isn't going to go into the depths about what a mix node actually does on the NIM network, but just simple installation from launching a new server instance on a respective platform, installing the relevant binaries, how to build it, how to configure firewalls, and then actually how to bond your mix node. So let's get into it. First and foremost would be to navigate to nimtech.net. And on this homepage, you can obviously navigate to download section. And then we scroll down and we have various components of the NIM platform. And what we will be using is the NIM mix node. But before we download this binary, what we can do is go into the documentation about how to run NIM mix nodes as a whole. So what you need to do is navigate to nimtech.net/docs, then select the mix node section. And then prior to that, you've also got this section called Building NIM. So it gives you all the prerequisites in terms of kind of the operating system that you would need to run this on, and then some of the commands that we would need to do to actually get everything in a fit and stable state. So the first thing we'll do, we'll go and launch a new server instance in a platform of my choice, which is going to be Linode. And what I'm going to do, I'm going to select the specific OS that I want to be running. My distribution there is going to be Ubuntu, the region that I want to run that in. And on our documentation on our website, it specifies the type of hardware that we actually want to run. So by navigating to mix nodes within the node section here and selecting hardware specs, it gives you an overview of kind of the core computing that you actually need to run a reliable mix node. So for this demonstration, we're going to jump back into Linode. We're going to go to a shared CPU. And we're going to try and get 2 CPUs. So a Linode 4GB should suffice for this. So what I'm going to do now is create this instance. I'm going to label it NIM mix node demo and create. Okie doke. Pass that in. And behind the scenes, and for this instance, I didn't go about configuring my SSH keys, which I would usually do. But what I'll do, once that server has been provisioned, we will then SSH, well, we would have SSH'd into it, but we'll connect via root. And then we'll start going about installing all the relevant packages that we need to actually have the system up and running. So now I've just opened up a terminal session and I'm going to SSH into my machine. Perfect. So now under the root user, what I'm going to do is go back to the Building NIM section on the website and just run a few updates. And I'm just going to pause the video whilst that happens. Perfect. Now we've got all the packages that have updated for this specific server. So I'm going to jump back into the documentation. So there's two ways that we can go about this. We can either download the binaries, as mentioned firstly on the introduction of the video, which we're going to adopt this time round. But if you are a software developer, you can actually install everything on the main machine itself. So what you would need to do is install Rust, and then go about checking out the respective version that is our current release head at the moment of our software, which is version 12.1. But in this example, what we're going to do, we're going to download the binary, then we're going to SCP that binary across onto the server, then we're going to go about actually initializing it and finding how we do that from inside the wallet as well. So what I'm going to do is now go back to the website, and within the download section, so nimtech.net/download, I'm going to download the nim mixed node binary. I'm going to save it to a location on my machine, and that's done. Now that the binary has successfully downloaded, what I'm going to do is SCP that binary across onto the server. So it's quite simple to do. What I'm going to do is then, usually I would set up an additional user on the server under the name of nim, as per the instructions on the nim website. But for this instance, I'm just going to run it under root. So I input my password. And whilst that goes about its business, I'm just going to pause the video. And now I'm going to log back into the box. So if we do an ls, perfect. We can see the nim mix node is successfully on our machine. So what do we want to do next? We want to make it executable first and foremost. So I'm just going to change the permissions on the binary. And to see that's effective, it is. Perfect. So what does it state next within the documentation? So let's go back to the docs itself, go onto the mixed node section, and let's scroll down. So there's a few commands that we can run to actually find out more information about the binary. So let's jump back into the terminal. Let's run a nim mixed node to see what's presented. And then we can do further commands such as version. We can pass in the help parameter. And it gives us an overview about how we would potentially instantiate our mix node. So the next thing we want to do is initialize this mix node. So how do we go about that? To do that, first and foremost, you're also going to need to download the nim wallet. And the nim wallet is downloadable at the same URL and the same location on the downloads page. So depending on your hardware or your machine that you're operating from, you can download the wallet of your choice here, and then that will sit in your machine. Once you open up the wallet, it will launch a page that then allows you to create a mnemonic. What you need to do is then store that mnemonic in a safe place, access the wallet, and then extract your nim address. So I won't go into the depths about this right now, but it's a very clear user interface and it's a very streamlined flow to actually get yourself a nim wallet address. So now let's dive back into the terminal session and let's go about initializing our new mix node. So from here, I can pass in the init arg, and it then prompts us to input 3 fields. Your host, which is your IP address where you're going to be running your mix node. Your ID, just your configuration name. So in this instance, I will say test. And your wallet address, something that we've just got from downloading and installing the wallet. So let's go about that. So to show my wallet address, what I'm going to do is go to an instance of the wallet that I've just recently opened. And as you can see, I've got some balance in my account already, and this is currently pointing to our sandbox environment, which is one of our test nets. So what I'm going to do now is copy the value from inside the wallet, transfer that across into the terminal, and then it's going to give me my configuration that will entitle me to bond my mix node. So let's do that. And as you can see, that's successfully initted a new configuration. And where this is stored, it's stored in this directory here, and it reads the values from this instantiation. So now what we need to do is navigate back to the wallet to bond our mix node. But prior to doing that, what we also want to do is go back to the documentation and just follow the sequence of steps that are provided within this. So as you can see, we've just instantiated and run this command, and now running our mix node. So we could quite simply run that with the configuration that we've just set up, but we need to bond it. But let's try launching it first and foremost. Run ID test. And as you can see, that has successfully launched our mix node. But now what we want to do is bond it. By bonding, it actually shows that you own that mix node, and then you can start to configure and receive packets on the mixnet. So what I'm going to do, I'm going to exit out of this quickly, clear what's on my terminal, and then go back into the wallet and input the configuration values that were displayed on screen. So a useful command there, I accidentally cleared my terminal, so it didn't display all the information I need to bond my mix node. So what I just did then, where the binary sits, I just inputted nim mix node, no details, and then passed in the ID. So I'm going to copy all these values and navigate to the wallet, go onto the bond section, and we know what we need to do here. We need to bond our mix node. Now I'm going to copy my Sphinx key, my owner signature, and there is a minimum amount to pledge, and that is 100 NIM tokens. Profit percentage is that if you are an operator and you want people to delegate to your mix node to earn rewards, you should be quite fair in terms of setting this profit percentage margin. So if you set 100% and people delegate to your mix node, only you are going to actually get those rewards. So be fair in your approach to actually setting your profit percentage. And if we copy the rest of the values, and then let's go about bonding this. So I'm just going to move my screen quickly, and this is against our sandbox environment. So I select bond, and we can see that transaction successful. Perfect. So now I know that has bonded, and to check that transaction successfully broadcasted on the network, we also have a block explorer. So what you can see here is just the mix node that I have just bonded. So 103, 103. So we can see that bond has successfully applied to our mix node. Last but not least, what we want to do is start that mix node up using systemd, and we want to configure the ports to allow traffic to actually be allowed in on the mix node itself. So back to our terminal, I'm just going to clear what's on screen. Then I'm going to go back to the documentation as well. So we just want to open up and configure our firewall. And I'm just going to do literally a copy and paste here and just install all the relevant packages that are needed. And then allow the ports to be open. Here we go. So, perfect. And now if we check the status on that, we should see these ports have been configured correctly. Okie doke, bear with me 1 second. So what I'm going to do now, I've just enabled all the ports and everything that have been mentioned within the documentation here. So now I'm going to automate the actual process of starting the mix node behind the scenes, so I don't have to worry about it or let it run by me manually kicking it off. So what I'm going to do, I'm going to create a service file, copy this across, and navigate to the respective directory to do so. So etc systemd system. What I'm going to do, vi nim mixnode dot service. So I'm going to copy this in, and because I actually haven't created the user profile in this demonstration, I'm going to actually be running it as root. I'm going to be specifying the location where it's being run from. Root. Here we go, get rid of this. Nim mixnode run. And the argument that we need to pass in here is the ID that we set it up as. So that would be test. So let me just insert that value here, test. And now if we go back into the documentation, now we want to start this, so we need to enable it. Just going to copy that across here. And that's done its business. And now behind the scenes, what we want to do is see our nim mix node kick off from the service file we just created. So one way we can actually do to check that is a journal CTL -u nim mix node. And here we go. As you can see, we have now successfully bonded our mix node. And in terms of actually listening to ports and it bonding from the wallet, we've done that. I'm sorry, this is a very kind of granular nutshell overview of everything, but if you do have further questions, do not hesitate to get in contact with myself or one of the team in our Telegram channels, which can be seen on the website here. And alternatively, you can also find us on Twitter, so twitter.com/nimproject. Thank you for taking the time to listen. And once again, if you do have further questions, don't hesitate to get in touch. Thank you.
And thank you, Nim, for this presentation. That was for today our last video presentation. We started off with a presentation by Anatol on the new ultralight mode on the swarm nodes. Then we dove into the opportunities with the Fluence network. Then we jumped into Avado with Stefan, and we closed off with the presentation by Nim. The day's not over. We'll actually continue with a discussion on Twitter. So on Twitter Spaces, there will be a discussion regarding decentralization and specifically hosting. So what we've seen today, if you want to set up a node, what does it mean? How does it impact the network? How does it impact the services that you're trying to aid with? How does it impact your, well, eventually your wallet in some cases? We're going to discuss that with Denis Hoyo, also known as Javamil, in his online Twitter Spaces broadcast from starting about now. We'll switch to Twitter Spaces. You can see the link for those who want to join in the program overview on our wearemillions.online website or at the Discord at the event list. It's a public platform, so anyone can join in. And a few guests have been invited to discuss this this sector, specifically the part about node hosting. One of them is Attila Gasso, one of our team members at Swarm. And we will transfer there now as well. Don't forget to claim your experience for your NFT avatar. And we hope to see you again tomorrow after the session on Twitter, where we will be showcasing a lot of beautiful projects. We're currently building their solution with Swarm storage integrated. So there's going to be a lot of nice, a nice tangible demos. Yeah. So thank you again, and see you on Twitter.